This is one of the longest range and most powerful intercontinental ballistic missiles in the world. It can, within 30 minutes, obliterate any target anywhere on Earth. Each launch can carry 10 to 16 nuclear warheads, with the destructive power of each warhead being 50 times greater than the little boy atomic bomb that was dropped on Hiroshima, Japan. The intercontinental ballistic missile Sarmat. The Sarmat is 35.3 meters long, with a diameter of up to 3 meters. It can be launched from a silo or from a moving vehicle. The missile launch process is relatively complex. Before launching, it requires the president or military leaders, based on strategic demands, to make the decision to initiate. Once the launch decision is made, the launch command will be sent to the control center. This command will be fully secured and encrypted. After receiving the command, the technician will verify it through a security code. If it is confirmed that the two codes match, the launch command will be approved. At this point, the technician will input the target coordinates into the missile's guidance system. The guidance system will calculate the optimal flight path for the missile to reach the target. After that, the launcher will insert two keys into the launch control panel and turn them to activate the missile launch system. A final check will be conducted. If everything goes smoothly, the launcher will press the red button on the launch pad, igniting and initiating the launch. First, the engine of the rocket's first stage will ignite, pushing the rocket out of the silo. The rocket will fly towards the target under the guidance of the control system. At the start of the flight, the rocket is steered in the direction of the engine through a universal joint that adjusts the rocket's trajectory. When the rocket reaches an altitude of 50 kilometers above sea level, the first stage of the rocket will separate, and then the second stage rocket will ignite. Powered by a two-stage rocket, the missile's speed at this point had reached Mach 10 minutes later. The second stage detached, and then the third stage ignited, propelling the missile to an altitude of 1,000 kilometers. At this time, the flight speed could reach Mach 20, continuing its journey. At this time, the gas propulsion engine at the front of the missile will fine-tune the missile to control its direction and trajectory. After 30 minutes, the missile reaches its final flight point. Stage 3, at this point, the missile separates, then the protective shell at the front of the missile will open, releasing all the nuclear warheads. Inside each nuclear warhead, there is a nuclear bomb, a guidance system, and a propulsion system. Each of these nuclear warheads can fly independently along its own path. When the nuclear warhead is at an altitude of 100 kilometers above the ground, as it re-enters the atmosphere, it will follow a precise path, flying to different targets. The navigation system will continuously adjust the missile's accuracy and detonate the nuclear warhead as soon as it approaches the target with tremendous explosive power, causing massive damage and radioactive contamination.